All right, boys and girls, welcome back to the drive-through for a Thursday edition that kind of feels like a Wednesday. Dare we call it Positive Thursday? We probably should not do that. It's probably experimenting with something that we shouldn't do. I'll shout out to my girl Hannah from my volleyball team, who is doing awesome and committed, and her grandma passed away yesterday, so my thoughts are going with her because she's had quite a roller coaster of a few days. So, look, all of this is related to what we're doing today. I would not waste your time. I hate having my time wasted. Okay? So I'm just going to draw myself a little axis, and we'll make a little key. We'll graph the first one in blue. So y equals 0. It's so simple, it's extremely easy to mess up. Okay? So, first of all, one thing that makes it very confusing is that this is our x-axis, right? And that's our y-axis. And I honestly get that wrong sometimes. So am I right about that? I am. Okay? So, when y equals 0, that means y is always 0. What is x? Whatever you want it to be. So we could have this be negative 3, 0, 2, 0, 17, 0. They would all satisfy that requirement. So here is what I'm saying is confusing. What is the name of the line y equals 0? The x-axis. And that's weird. The x-axis is the line y equals 0. Okay? So, if we're trying to do, we'll do this one in pink. The rule is that x always has to equal 4. So what are some points that'll work? 4 comma anything. 4, 0, 4, 5, 4 comma negative 2. Doesn't matter. So what's staying the same? X is always 4. And so the irony being that if it's an x equals, that line is going to be parallel to the y-axis. Okay? So then finally, y equals negative 3. I'm going to graph that without writing down any points because I think I have a pretty good grasp for what this is now. I got to go down 3. Okay? And those are horizontal and vertical lines. So just an important thing to review before we start today. So far, so good? Okay. So, we're going to go over this answer. Then I'm going to pause the video and show you guys a magic trick that involves calculus. This is kind of your introduction to calculus. Okay? So, let's do it with a chart. On the left side, let's write the number of plays. And on the right side, we'll keep track of our yard line. Okay? And this is legitimately a strategy that some good coaches, like Nick Saban does this. If you're ever going to get a touchdown, he teaches his defensive backs to just tackle the guy. Don't let up a touchdown. So, if we had run 0 plays, what yard line were we on? The 10. And then Sycamore ran a play, and the Oak Hills people just tackled the wide receiver. So the ref throws a flag, and so Sycamore doesn't get a touchdown, but what do they get? They get half the distance to the goal line, so now they're at the 5. Okay? So then this just keeps happening. After 2 plays, they're at the 2.5 yard line, right? And then after 3 plays, they're at the 1.25 yard line. And then I'm going to need some help on this. And then after 4 plays, they're at the, is it 0.675? What's, thank you, 0.625 yard line? No. No, that's where the end of the ball is. The edge of the ball. Yeah, that's how they mark a football, is by the nose of the football, right? Agreed? Okay, so after 5 plays, it's still first down, because you get a new first down every single time. But now where's the ball at? Okay, and after 6 plays, And so maybe you start to realize that this number will never get to 0. It'll never get to 0. You're just getting perpetually halfway closer. And when people started thinking about this, they had to start thinking about, well, what if we could run infinity plays? And that literally is where the birth of calculus came from in somebody's mind, which is this guy, Leibniz and Newton. They're the people that started to think about calculus, which is, okay, I understand that infinity is a ridiculous concept to you guys, but like so is the sun. The sun is so far away that like it's not even worth measuring. Do you understand that? You could almost consider it infinity miles away because it would calculate out to be that way. And so I'll show you guys a couple examples here. I'll show you one example in the video and then I'll go into the magic trick. Okay? What is a regular, okay, this is a square. How many sides does it have? 4, okay? Well, then you got like a hexagon. And I'm trying to draw a regular hexagon. So that's got 6 sides. And then a decagon has 10 sides, and I can't draw one. But it looks something like that. And what does a regular 100-gon look like? It just looks like a circle. It just looks like a circle. Okay? And so, if you had an infinity amount of sides, it would just be a circle. A regular infinigon is a circle. So the limit, as the number of sides approaches infinity, becomes a circle. So I'm going to pause the video real quick. Okay, so I just walked through the piece of paper. Your minds were not blown. Most of you didn't care, which is totally fine. Just so you know, that's what got you here, not your inability to do math, because you're very good at math. It's the fact that you don't necessarily care as much about math as your cohorts. And just so you know, I think that's totally okay. I just hope that you are great at something else, or that maybe you're opening up to being interested in this. Here we go. So, most of this looks familiar. It's just like last night's homework. Okay? So, I'm not even going to pull up my graphing calculator on the video, although that is how you're going to do these. Okay? So when you pull up your graphing calculator, you put this in, and then hopefully you sketch a graph real quick, and then you hit up your table. It says to put 3 points on there. I'll tell you, on this worksheet, I did not adjust my scale on my axis at all. I just used like, so look, one of the points is -1, 5. So that's a nice easy point to put on there. Okay? Another point is 0, 1. And then the other point I put on there is the point 1, 0.2. But here's where all this talk is trying to line you guys up. Okay? If you put in a 10 for x, I want you to just think about what's going on. It's 1/5 times 1/5 times 1/5 times 1/5. How many times? 10 times. What happens when you multiply by a fraction that's less than 1? What happens to the answer? It gets smaller and smaller and smaller. But will it ever get to 0? It will not. Well, that, to answer your question, is what an asymptote is. It is the limit. It won't ever get there. In our little warm-up example, it's the goal line. Okay? So, this is going to go up forever in this direction. And it's going to go up really fast. But as we go over here, and this is so hard to draw, it's just going to keep getting closer and closer to the line without ever touching it. If you put in 1,000, your calculator might tell you that the answer is 0. But it's not. You know it's not. Because if you sat there and typed in your calculator 1/5 times 1/5 times 1/5 times 1/5 1,000 times, there's no way the answer could be 0. Even though on your table, in your calculator, it probably tells you that it's 0 because it's estimating it. Does that make sense? So what we want to do is draw a dashed line or a dotted line. where the asymptote is. That's just kind of like the general accepted math way to do that. All right, so domain. What are we allowed to put in for x in this problem? Anything, exactly. Great for you guys that said that with confidence. Now it's our last chapter was our domain that was changing. Now it's our range that's changing. So what values can we get for, remember, range is output or range is y. What values can we get for our y in this problem? Anything above 0. Excellent, Hadi. Not greater than or equal to 0. And then, honestly, if you can get the range right, the asymptote is always the equals version of that. That's the line y equals 0. Remember, the line y equals 0 is the x-axis. So that's all we're saying. The asymptote is the line that we will almost reach but never get to. So that's your new word of the day. Okay? All right, we'll do one more. We're going to do number 2. Once again, you would put this in your calculator, and you would get that 0, 2 is on your table. And you would get that 2, 4 is on your table. Is that right? That's not right. Oh, 1, 4. That's more like it. And then 2, 10 is on your table. And then as you go this way, you'll see that this one's a half, I think. It's actually not. It's like less than that. It's here. So maybe you can see on your graph or from your table that our asymptote has changed. Okay, what is our asymptote in this one? It's y equals 1. Very good. So I'm going to make a dotted line right there. I'm going to do an arrow and an arrow because it does keep going. All right, my domain is, again, all reals. What's my range this time? What values can we get for our y? Well, they can go all the way up to infinity, but they can only be as low as 1. Very good. So y has to be bigger than positive 1. And my asymptote is y equals 1. Okay?
Scroll from the table in the calculator, like once you get to like x 10.
Love it.
It only says 1.
So Jacob just pointed out a great little thing. As long as you're smart enough to use your calculator without trusting it. Okay, you don't want to marry it, you don't want to take it on a date, but you can use it, because if you scroll up in your list, you'll start to see that 1 repeats for the output. Remember that your calculator is estimating to get that, but that is a great way to find your asymptote. Find out where it repeats on your table. Okay? You can always use that feature. All right, thanks for listening. Boom!